Good morning, good morning, good morning, my warriors. Welcome aboard to the Zero to Hero series with me, Shreyas, your master teacher for physics at Vedantu going live. How is everyone? Hi Vijay Kumar, nice to see you with the new display picture. Hello Nancy, hi Preeti, hi Naman, hi Divya. Hello everyone. Hi Shreyas Kapri. Hello Ria, hi Ankit. Good morning guys, good morning. So those of you are new to this channel, I'm Shreyas and I teach physics not only on this channel but also on the regular Vedantu platform. I have been teaching for more than 10 years, and before joining teaching I was in the corporate sector, and I left my corporate job so that I could teach. I had almost scored full marks in physics during my time. So when I wrote my examination I had almost scored full marks, so I thought I should actually end up teaching and I should spread this joy of learning to everyone. And now I'm here on YouTube in Vedantu so that my learnings, my teachings can spread to millions and millions of people out here. So guys, thank you very much for all the support that you have been showing all this while, and I'll continue motivating you, continue teaching you, making sure that you guys get into IITs just like the rest of my students who have studied under me. With me, Shreyas, and guys, you can follow me on Shreyas_Vedantu. That's my Instagram handle. Welcome aboard everyone. Hi Kasturi, hi Game Changer. Yes, definitely we are going to change the game. Hello Snehal, hi Gopala Joshi, hello Pooja Chauhan, hi Balaji, hello Sakti, IITN. Yes, definitely Sakti, the day is not far. Don't worry. Hi Sparsh, hello Gayatri, hello Ria, welcome aboard, welcome aboard. Let's begin with our session. And before we start, do not forget to smash the like button down there in case you have forgotten to do so. And if you are new to this channel, do not forget to freely subscribe to our channel so that all of us can teach you all the important aspects of physics, chemistry, maths, give you important strategies, tips, tricks, etc. all in English medium, because this is an English medium channel. And if you think your friends are unaware of this channel, do not forget to share these videos with your friends and relatives. So let's get going guys. Hi Vikram. Yes, IIT Bombay, Mr. Intelligent, hello, welcome aboard. Vikram is with all his swords out. There is fire in his body. He wants to fight. Yalini, Vanakam. And I know there is a lot of fire burning in your body, your mind. You want to get into that IIT. You want to smell the fresh soil from IITs and all the top engineering colleges. How many of you cannot wait to go there? Sir, I want to go into an IIT, I want to smell the soil, the fragrance when the rains will fall in the monsoon. I want to get that smell. I want to visit that beautiful campus. I want to be under the shade of all those trees. I want to mingle and I want to make new friends. How many of you? Yes, a lot of you, I'm pretty sure. Yep. Very good. So welcome. Hi Rakesh, good morning. Hi Badri, welcome aboard. Hi Vishwa. Yes, so guys, I know the journey is just about to be over. You're just there. So guys, if you still want to consider joining the crash course, please do so, because remember, this is the last and final attempt which you would get, which you can do it sincerely without having the board's examination clashing with the JEE Mains. I feel the April's examination attempt has been postponed, so it might again clash with the board examination because boards also has been postponed. So I feel you should thoroughly prepare for the May attempt of JEE Mains. Give it all that you have, finish it all once and for all with really good results. So guys, please consider joining the crash course because it has all the 11th and 12th standard portions. Replays are available in case you miss or you want to revise anything. Also, you get teachers like me only in the crash course, and you have unlimited doubt solving from morning till night, including in-class teacher assistance with a 2-teacher model where the second teacher is continuously assisting and helping a small group of students. And you have test series included in the crash course. Also, you get notes, handwritten plus assignments in the crash course. So all of this at a very affordable price of 10,000 rupees. Now 6,000 rupees when you use the coupon code SHCC. The link for joining the crash course is there in the description box. I'll be telling you more about it in a while. So for now, let's talk about alternating current, AC circuits and LCR circuits. Let's get going. Yep. Okay. Balaji, I think it can't happen. I'm not sure what can't happen. All right. Hello, Yalini. Welcome aboard. No, Ankit. Dreams can become true. Trust me. Trust me. Yes, Balaji. I know board examinations are there for many states. So that's why you need to choose wisely which attempt you are going to give. For CBSE people, it's wise enough to give, the May attempt. Good morning, Kasai. Hello, Vignesh Arvind. Hello. Yes. So, Badri, definitely, why not ping me on Instagram or type in a comment after the video or any one of my past videos, just recent ones. I'll definitely end up replying to all your problems. Okay. So, let's now concentrate. First of all, remember the EMF generated by a rotating coil. This is basically generation. This is AC generation formula. This is AC generation formula, guys. So N is the number of turns, A is the area of the coil, B is the magnetic field, omega is the angular speed. So if you take a coil of N turns, rotate it in a magnetic field, this is the EMF that you are going to get. Remember, in AC circuits, the current and the voltage will have some phase difference. This phi is nothing but the phase difference, all right, between. So this is the phase difference between the voltage and the current. So always the current and voltage are, you're going to see most of the times they are going to have some kind of a phase difference out there. Thank you, Vignesh. Glad you like the Killer 5 videos. So Killer 5 videos for JEE Advanced, Zero to Hero series, to make sure you actually become a hero in mains examination. This is all one shot videos which will help you for the May attempt or even when the next examination is going to happen. Next up, average current. Very important. Average current is 0 because the amount of positiveness is equal to the amount of negativeness in one cycle. So that's why the average current, average voltage is always 0. But RMS, the RMS value is the peak value. This is the maximum value by √2. Remember that. So this is nothing but the max value. So the max value by √2 is called as the RMS current or the RMS voltage. So guys, if you have forgotten what RMS is root of mean of square. So that means you take the average of the squares. So 1 square plus 3 square plus 10 square plus 5 square plus 7 square. So you take the average of them and take it under the root, that's RMS value. And remember, the power is I squared R. So energy will be I squared R into T. This T is time. So this T is time. So if you just look at this much part, only this much part is power. This much part is power. So power into time gives you energy. Remember, I squared R is the formula for heat dissipated through a resistor. Yep. So Snehal, I know there are a lot of formulas. So Bacha, Snehal, since you have time, I would sincerely request, if you want to study the chapter from scratch, like absolute zero, I have created an AC lecture. 2 lectures or 3 lectures are there on AC circuits only in the Flash series. So those of you who do not know where it is, I'll tell you guys. See guys, you can go to JEE Enthuse channel. You can go to the playlist out here. Okay, just go to the playlist. And if you go to, let's say, the physics playlist out here. Okay, so you go down. All right, I have arranged it systematically, all the chapters. Now somewhere down here, where is it? Electromagnetic induction. Yes, over here. So I think it should be there over here. Oops, sorry, it's not in EMI. Okay, it's somewhere else then, I guess. Okay, please end it. Skip ads. Oops. Where is it? Where is it? Somewhere here. Maybe I'm not able to see it right now. Oops. Okay, it's there, guys. I'm not sure. I'm not able to find it right now. Wait. Okay. Well, where did it go? It was there here only. Okay, maybe if it is not there, I'll just create a playlist. Don't worry about it. I think it was there somewhere. Was it there in modern physics? Nope, it's not there in modern physics. Okay, I'll ask the admin team to create a playlist. Don't worry about it. Okay, I'll just ask it. Okay, don't worry. Yeah. So, Sai Shashank, in fact, I have created a session on communication system as well. Communication system, I have already made a video on that. If you again go to the playlist out here, it's there. For communication system, it's there. That I'm sure. Okay. So, if you see 0 to hero series, in 0 to hero series only it is there. Okay. See, you can see that 0 to hero in communication systems. So, it's already there. I have made a in detail lecture for communication systems. So, you don't have to worry about it. Okay. Hi Laksh, good morning, good morning. Hi Bhaskar, welcome aboard. Okay. So now reactance. What is the meaning of reactance? Reactance is equivalent of resistance in AC. So it is equivalent of resistance in AC. That is the meaning of reactance. So capacitor has a resistance of 1 by omega C. An inductor has a resistance or basically equivalent is called as reactance. It has a reactance of omega L, and impedance is the total effect. Impedance is the total of, inductor plus capacitor, all right, plus the actual resistor. The total resistance, all right, total resistance, all right. So that is what is basically impedance. So total resistance effectively for an AC circuit. So in AC is called as impedance, and remember the formula for Z is found out using vector addition. Remember all these quantities are to be represented in a phasor diagram. That's why you have learned phasor diagrams in 11th standard, which will be useful in 12th. So actual resistance, if you show it like this, the inductive reactance has to be shown upwards and the capacitive reactance has to be shown downwards. So think of it like 3 vectors, and the addition of these 3 vectors gives you Z. So what is E naught? E naught is nothing but the max, all right, max voltage, and I naught is nothing but max current. All right, guys, you don't have to remember this formula. I mean, this is straightforward. I'll tell you why. I'll tell you why this formula is straightforward. See guys, voltage is I into R, correct? V is IR. So if you have the total voltage, all right, is total current into, instead of resistance, you have total resistance, which is called impedance. So this formula always works. So total voltage is current, total current into total resistance, which is called as impedance. So that is that only. It's nothing but Ohm's law at the end of the day. Yep, that's all. Now if you add them vectorially, you will get Z vector, which is the impedance, which is the total resistance of the circuit. Keep this in mind. So generally what you do is you show this vector somewhere like this over here. So you show the XC vector down here. So basically this vector minus this vector is only this much vector. So this is XL minus XC. So this vector minus this vector is only this much vector. So this one is basically your Z, which is your total impedance. That's how you get it. Yep. I hope you remember that. Yes, this is equivalent of Ohm's law. You can even write this as ERMS by IRMS. That's also fine, because both numerator and denominator are divided by √2. It's okay, it's permissible. You can do that. Remember this. Very good, Ishan. Very good, Akansha. Yes, Sakti. Yes, Vicky. Yes, Vicky will be doing that just before, the JEE Mains examination. But for February attempt and for KVPY and for March attempt, I have revised all the 11th and all the 12th formulas. All those sessions are still there in the past videos, in the playlist. Again, it's there in the playlist. So I would request you, Vicky, in case you're not able to find it, leave a comment below the video. I will definitely ping you, or I will comment or reply to your comment with the link of the playlist or the particular video. Okay, don't worry about it. Yes, Yalini, I'll definitely check. Okay, now don't have to remember these formulas separately. Don't have to, because I just gave you the vector diagram the phasor diagram. So if you know who is the resultant of whom and whom, that's it, and you just have to draw it vectorially and just solve the problem as if it's a vector problem. Nothing new. Understand that. So say for example, there is only capacitor and resistance. Capacitor and resistance. So capacitor and resistance, that's it. So just show R and XC vectors and just solve them vectorially. I will help you out with all these formulas in a problem. Now all these formulas look very confusing, trust me. You get confused. Sir, my God, how the hell am I going to remember all these formulas? Guys, you don't have to remember these formulas. This all is there in your book, but you don't have to, because once you know that, yeah, come on, this is R, acha, this is XL minus XC, and you know that this is Z, guys, use Pythagoras. What is Z? Z square will be equal to R square plus XL minus XC whole square. Correct, guys? Use Pythagoras. This is using Pythagoras, guys. Using Pythagoras. And now you know the value of XL. XL's value is omega L and XC's value is 1 by omega C. So if you use that, it becomes very easy to understand. Else you will unnecessarily waste your time. Remember that. And last thing that I would like to tell you, that this angle over here is phi, which is your phase difference. Okay, so don't have to do all of that. Yeah, that's why don't forget all of this. Forget all of this. Just forget all of this. Okay, just forget all of this. The only thing I want you to focus on is this one right now, the transformer part. Guys, remember, if the number of turns on the primary side and the number of turns on the secondary side are N1 and N2, the ratio of the turns N1 by N2 gives you the ratio of the voltages on the primary on the secondary side. So a transformer is meant to step up the voltage or step down the voltage. So ratio of the turns is the ratio of the voltages. But remember, E1 I1 is E2 I2. That is because you know this is input power. This is in power and this is out power. Power is nothing but voltage into current. So that's why E1 I1 is E2 I2. So remember, if you see from here, E1 by E2 will be in fact I2 by I1. So be careful about these relationships as well. Yep, Rashmilingam, all the slides will be there. Yep, don't worry about it. Okay, cool. Now, one last thing before we go ahead. This one. This is the power formula Vrms, Irms, cos phi. You should know this. The power generated in a AC circuit, alright, the power loss, in the AC circuit is Vrms, Irms, cos phi. So very, very important formula, alright, for the power loss in an AC circuit. In fact, all the slides will be shared in the Telegram group. Don't have to worry. Just join the Telegram group. The link is there in the description box. Let's start with some problems. So, you know, this is how the wave platform is going to look like in case you are going to join the crash course with all the chats, the teacher available over here, you know, all the animations, the slides will be visible over here, and you can ask any doubt that you have in the crash course using the doubt facility by sending screenshots and chatting with our doubt experts out there. So let's start with some problems. Don't worry, you're going to see how easy the AC chapter is if you just have a little bit of patience. By the end of these next few questions, you will truly feel like a hero. You will understand just remembering the formulas is a total waste. Observe that. Just observe that. Okay. Now, if in a series LCR circuit, the voltages across L, C and R are V1, V2 and V3 respectively, then the voltage of the source is, come on guys, think about it. Come on, think. Yes, power and power factor are different. I'll be coming to that in a question. I'll tell you about it. Hold on. Come on guys, think carefully. Okay, come on, Abhi Bhavi, Yes, you're a little bit late. Some of you are saying A. Yep. Come on. Okay, so let's have a look. Some of you are saying B. Well, guys, let me tell you, the answer is actually none of these. No, the answer is none of these. I'll tell you why. The answer is none of these. Frederick, yes, you're a little bit late. See, guys, let's understand this. If I tell you the voltage across resistance is 3 volts, the voltage across inductance is, let's say, 5 volts, and the voltage across capacitance is 2 volts. Example. If I ask you what is the total voltage across the circuit, what is your answer? Is it 3 plus 5 plus 2 or something else? Think about it. Think. This is what I'm going to teach you now. Now you will never need those formulas. Observe how I'm going to tell you this AC chapter now. 3, 5, 2. What is the total voltage across the circuit? Think about it. No, yes, you have to do vector addition, Balaji. Think about it. Yes, Anita, correct. So guys, the actual voltage is, first show 3 volts over here. That's the resistance. Always resistance is horizontal. Then inductance L is vertically up. So go vertically up. How many volts? 5 volts. So go 5 volts up. Okay. Then capacitance, how many volts? 2 volts. So go 2 volts down. So now 3 volts plus 5 volts plus 2 volts. This is what you need to do. What you are going to get is this vector out here. So this is the total voltage. Now believe me, if this is 3, how much is this? This is 5 minus 2. Oh, coincidentally, this is also 3 volts. This is 3, so this is also 3 volts. So guys, this black line will be 3 square plus 3 squares root. That means it's going to be 3 root of 2 volts. How did you get it? You got it using vector addition. That's it. Did I use any formula? No. Just remember this. R horizontal, L on the top, C below. Just remember this. L on the top, R here, C below. If you remember this, your complete AC chapter is sorted, most of it. I hope this is clear. Yep. Understood? Okay, somebody was asking, sir, what is quality factor, formula and all that? So, well, the questions on that might not come so much, but still, if you just want to know what the formula is, the formula for quality factor, okay, the quality factor formula for a LCR circuit. So quality factor, all right, the quality factor formula, if I remember it correctly, guys, yes, it should be 1 upon R. Yes, 1 upon R and root of L by C. So that's the quality factor formula. Okay, so that's what it is. That's the quality factor formula. And some of you are asking, what is the difference between power and power factor? See, when I say power is VRMS into IRMS into cos phi. Okay, so understand this one over here is called as the power factor. This is called as the power factor. Understand that. So the power factor can be 0 and at max 1. So maximum value is 1, all right, minimum value is 0. So between 0 and 1, that's what you're going to get. So the power factor will always be maximum 1 and it will be more than 0, one of them. Okay, I hope this is now clear. Yep. Is that clear, everyone? Everyone understood this? This is the formula for power factor. This is power factor. This is the total power formula, VI cos phi. Yep. I hope this is clear. So that formula is only for impedance. No, sir. Which formula? Vishwa? This one or this one? Come on, think about it. Okay, all these formulas are for LCR circuits. This is not just for impedance or just for capacitance. This is for LCR circuit in general. Okay, I hope that is clear, Vishwa. Oh my God, Abhinav, if you want to impress someone and crack JEE, that's also okay. As long as you crack JEE, I'm happy with that. Okay, cool. Let's get going. So I think I've answered all your doubts. Some of you are asking some of the doubts. Okay, chalo, let's get going to the another question. Now you're going to understand complete theory through the questions. Believe me on this. The voltage varies with time according to this equation: 100 sine pi t cos pi t T is in seconds, V is in volts, then which of the following is correct? Glad you got it, Charu. Nice to know that. Okay, come on. Think clearly. Very good, Balaji. Clear, very good. So for the question I did the vector. Well. Vishwa, you can use that vector addition for anything. LCR, LC, RC, R, LR, you can use it. Okay, it will work. Okay, so I hope that is clear. Okay, so let's see. Some of you are already saying some option. The peak voltage is 100 volts or 50 volts, or 100 by root 2 volts, or is the frequency 50? Come on, think about it. Suyog, COEP is very good college. In fact, I had conducted a lecture on the top colleges apart from IITs and NITs. So in that I had mentioned about it. Please watch that video which is there in the past ones in our channel. So guys, first of all, this same thing can be written down like this. 50, all right, into 2 sine pi t into cos pi t. Now the reason for writing that, trigonometry formula, 2 sine theta cos theta is sine to theta, isn't that correct? So this will be 50 sine 2 pi t. Using the trigonometrical identity, sine 2 theta is 2 sine theta cos theta. So guys, can't you see from this that this is nothing but the max voltage, and this one is the omega. Now if omega is 2 pi, but remember omega is actually 2 pi f, so how much will you get the frequency as? 1 hertz. Now do you see the frequency is actually 1 hertz, 50 hertz is wrong, it's wrong, and the max voltage is 50 volts, so hence this option is correct. I hope you guys saw that. Very good. No problem, Venkat. I mean, if you're in class 11th, I feel you should attend the Pathfinder series, which is for 11th to 12th moving, or if you are 10th to 11th moving, then we are starting up with bridge course and then the long-term batch for 11th standard students. So just hold on, don't worry, have some patience, don't worry, we're coming up with a series for all of you. Very good, excellent. That's why the answer is C. Hello Shreyas Sir students, welcome aboard. Very good Sai, very good Kora, very good Ankit, Samla, Yalini, excellent. Let's do another question. Guys, trust me now, look at this question, you'll slowly get it. Look at this, this has inductance, this has resistance. The question is, what is the amplitude of the current in the circuit if the voltage is this much? This is a voltage applied, resistance is there, inductance is there. So guys, first of all think, right? If you have just a resistance and an inductance and you are connecting it to an AC source, all right? You have inductance, you have resistance. So if you had to draw that vector diagram, how will you draw it? Think about it. You will first draw resistance horizontally, and since it's inductance, draw impedance XL vertically up. Remember, that's what I have been telling you. So the total, this was the reactance, this was resistance. The total Z will be here. The total Z will be here. And what will be the value of Z? The value of Z will be R square plus XL square. Now what is XL? What is XL? Is it your banyan size? Is it your t-shirt size? Come on, what is it? What is XL? XL is omega L. Alright, omega L whole square. That is Z. Remember that. Now, I have told you about Ohm's law. Ohm's law equivalent. Just like voltage is current into resistance. Just like voltage is current into resistance. Same way, if you use Ohm's law, the total voltage is total current into impedance. V is IR. So guys, I will be V0 divided by Z. So what is Z? This one. So R square plus omega square L square. That's the answer. I think it's option A. Is that clear? Okay. Yes. Theta was different in the last question. Special, is it? Okay, let me just check. All right, don't worry. But yes, this is the answer. That is option A. Yup. So remember that. Okay. So theta was different on, oops, was it? Arey yaar. Guys, this 100 has come by mistake. I'm so sorry. This 100 has come by mistake. This was not supposed to come. I don't know why this 100 came. This was not supposed to come. I'm so sorry, guys. Okay. When we gave the question, this 100 was not there. I think this was a misprint. Okay. So I'll just remove that. Thank you. Who is that? Somebody pointed it out. Yes. Thank you for pointing it out. Yep. Thank you. Okay, so I'll just correct it in the session PDF. Don't worry, don't worry. Okay, I'll just correct it in the session PDF. All right, next one up here. Hello, Kashmir the Paradise. Hello, Vishrita. Hello, Jaydeep. Welcome. Yes, XL minus XC, right, is in LCR. So, Sakti, L is always on the top, capacitance is always on the bottom, resistance is always horizontal. So, keep that in mind. Alright, L is on the top, resistance on the horizontal, C below. So whether it is XL minus XC or XC minus XL will depend on who is more. Is XL more or is XC more? If XL is more, then it will be XL minus XC. If XC is more, it is going to be downwards, so it will be XC minus XL, just like vector addition, that's all. Okay, cool. Now, how about this? The inductance has high resistance for AC, DC, same for both or depends? Come on, think about it. Come on. An inductance has high resistance for AC, DC, same for both, or does it depend? Okay, let's do this. So first of all, remember our Banyan t-shirt formula. What is our Banyan t-shirt formula? XL, right? So this is your size. How many of you have t-shirt sizes XL? Come on, let me know in the chat boxes. So XL is omega L. That's what it is. Now for AC, omega is large. For DC, omega is 0. Correct? For AC, the current varies, the voltage varies, so omega is large. For DC, the omega is 0. That means for AC circuits, XL, the Banyan size, the t-shirt size will be large. For DC, the XL value will be 0. Is that clear? So guys, that means for AC circuits, the inductance has high resistance. It has high resistance for AC circuits. Understood? Very good. Very good. I got size small. Gayatri definitely not. Balaji not sure. Why 0, Samla? Because omega, there is no change in the current. Current is constant. What is the frequency of a DC circuit? There is no change in polarity. It's a constant voltage. That's why omega is 0, XL is 0. Is that clear? Thank you, Chandresh. Okay, let's get going. Now, next one coming up on your screen. An AC voltage is applied to a resistance R and inductance L in series. Resistance and inductive reactance are both 3 ohms. What is the phase difference applied to the voltage and what is the current in the circuit? Okay, I think the current in the circuit has not been mentioned over here, so just ignore that part. Just think about, okay, just ignore this part. Just think about what is the phase difference of the circuit. Okay, think. My God, Badri is triple XL. Okay, Yalini is medium. Good. Very good, Samla. Yes. Okay. Now, whoa, Sakti got headphones as a prize in the vote. Very good. Very good. Now I'm guessing that you are going to listen to all our classes on headphones nicely. Very good. Now, I'll tell you what. See, remember R was horizontal. What was I telling you? R is horizontal. R is horizontal. And inductive reactance is vertical. So remember L is on the top. So XL, again Banyan size is coming, guys. So come on, XL is nothing but again 3 ohm. So what will it be? The Z will be over here. The Z will be over here. I hope this is clear. So guys, this is nothing but phi. I was telling you, phi is the phase difference. So what is the value of phi, guys? Isn't it 45 degrees? Because this is 90 degrees. This side and this side are equal. 45, 45, 90. 45, 45, 90. So the answer must be pi by 4 radians. Very good. Don't have to do anything crazy. Don't have to remember any formula. Tell me one thing, how many times I have been using formula apart from XL is omega L and XC is 1 by omega C? Hardly anything. And basic formulas that you should remember, average current is 0, RMS current is max by root 2. If you know that, most of the problems get solved. Remember, and the power formula, Vrms, Irms, cos phi. Power formula, Vrms, Irms, cos phi. So most of the things get solved. That's what you are saying. It's all about vectors. Unnecessarily people teach you in a very difficult way. Would you remember recommend flash series or 0 to hero series for completing backlogs? So Bhargav, if you are preparing for the May attempt, I would say 0 to hero, but there will be some topics which you are very poor at, very horrible at, or you are not so confident. For those topics exclusively you can see flash series, so that way you will save on time. Okay Bhargav? Okay. Okay, yep, let's do that. So Shubham, there is a beautiful functionality. I don't know if you know this. Even in a live class, let's say we are watching our own class out here. I don't know how many of you know this. So when you are watching Virat Kohli, no, let's not watch Virat Kohli. We will watch him in the evening. All right. So if you are watching a class like this, you can take the slider back. You can go back in time. This is called time machine, guys. You can go back in time. You can go even behind. Yeah, you can go as much behind as you want. So this is your time machine, guys. And you cannot go ahead of time. That's the unfortunate part. So I cannot scroll it afterwards and see what I'm going to do next, because that would be crazy, right? Okay, think about it. Okay, so that's what you can do, guys. Okay, cool. Let's get going to the next one. Yeah, very good, Sai. You should remember the formulas by logic. How about this question? In an AC circuit, the instantaneous EMF and the current are given by. Instantaneous EMF and current are given by. So, in one cycle of AC, the average power consumed by the circuit and the wattless current are. If the average current, what is the average power consumed and what is the wattless current? Come on, let's think about it. Okay, come on. Think. How are you going to do this? Sam, there is IPL going on, but you should not watch it. Okay, you have to watch us on JEE Enthuse. Okay, Piyush, good, you're back. Okay, come on, think. So I think I just told you about it, Bhargav, that you should watch 0 to hero and only for specific chapters watch this flash series. Okay. स्क्रीन के अंदर स्क्रीन, स्क्रीन के अंदर स्क्रीन, कांदा के अंदर कांदा, कांदा के अंदर कांदा, बॉक्स के अंदर बॉक्स. Oh my God, concept के अंदर concept, concept के अंदर concept, concept के अंदर concept. That's what JEE Advanced is. Okay, let's solve the problem, guys. Let's solve the problem. So, first of all, what is the average power consumed? Okay, B पक्का, अच्छा, इतना पक्का. 20 पक्का, कच्चा पक्का. Okay, so I'll tell you what. We just saw a formula. P is Vrms, Irms, cos phi. This was the formula. What is RMS? Max. Look at this. What is this? Max. Alright, this is max divided by root 2. Correct? That's RMS. IRMS. This is again max. Alright, this is 20 by root 2. And phi. What is phi? This is phi, guys. This is phi, correct? So it is cos of 45 degrees, correcto? So this will be 100 into 20 divided by 2 into 1 by root 2, because cos 45 is 1 by root 2. And that means, what are you going to get? 2, this will become 10. And this will become how much? Oops. Yeah, 100 into 10, 1000 divided by root 2. And that is the answer. Oh, but I have not yet confirmed the second part, but there is only one option with 1000 by root 2. But still, for our satisfaction's sake, let's find out the second part. See guys, the question is, what is the wattless current? Now, not many people know about this. Now, let me show you what it means. Remember this triangle. AC is all about triangles, angles, vectors. That's all. That's all. Vectors, angles, triangles. Remember VI cos phi, which was over here, VRMS, IRMS cos phi. This is VI sin phi, and this is VI. This is called as power triangle. Just like you have love triangle, what is this called? What is this called? This is called as power triangle. Okay. Now what are the three people out here? VI cos phi, VI sin phi. This is phi. This is phi. Okay. Chaitra, you don't have to pay anything to watch 0 to hero series. I mean, if you want to pay, I am happy. You can definitely pay, no problem. But you don't have to pay, bacha. Now, understand what is this VI. This VI is the power which you would expect it to be. Understand? Understand. So, this VI is basically called as your apparent power. Like, if you have a fool who does not know anything about AC, if you have a fool who does not know anything about AC, he does not know voltage and current are not in the same phase. If you tell him what is the power formula, he just knows DC, guys. He does not know AC. So that fool will tell voltage into current. That is that foolish power. Think of it. That is that foolish power. Yes, that is that foolish power. He does not know that there is a phase difference. But this one is a person who has studied under Shreyas Sir, and that to 0 to hero. He has attended 0 to hero in AC circuits. He knows that this is nothing but the actual power. So guys, understand, this is nothing but the actual power that will be lost. Understand that. So this is the actual power because of the phase difference. So this is the foolish power, the apparent power which will be there, but this is of no use. This is the actual power which will be lost. Now this one is the contribution. This one is the contribution for basically wattless current. This is that useless part. See guys, the VI contained useful part, the actual part, and this is the useless part. This is basically called as wattless current. What is it called? What is it called? This is called as wattless current. Yes, this is basically the current. This is the power which keeps on actually oscillating between the inductor and the capacitance. That's what it is. This is basically the power which keeps on oscillating between the inductance and capacitance. Remember one thing in life. Actually, just remember one thing in AC. Out of L, C and R, there is only one guy which will actually take power, lose it. The other two guys are gentlemen. Who are those two gentlemen and which is that culprit? Come on, answer in the chat box. Thank you, Chaitra. Thank you, Frederick, so much. There is only one guy who is the culprit among the three, L, C and R. The other two are actually Bechara Pavam. They are Bechara Pavam people. They are gentlemen like people. Who is that culprit? Think about it and tell me, answer in the chat box. Think about it and answer in the chat box. Yep. Who are those Pavams out of L, C and R? Come on, answer in the chat box. Akriti says resistance. Yes. No. Naman, no, not R and all. Yes, the two, no, it's not capacitor. L and C are the Pavam people. Remember that, guys. Okay, so L and C are basically Pavam people. They are not going to lose any power. This resistance is basically that evil guy. Yes, he is that evil guy. Yeah, he is that evil guy. Remember that. He will actually, there is loss in power because of that resistance. So when you draw the power triangle, this VI cos phi is because of that resistance. This VI sin phi, that is basically the power which keeps juggling between L and C. L will be like, hey, take this power. C will be like, okay, now wait, you take this power. So again, L will catch it and L will be like, okay, wait, you take this. So they keep on juggling that power. That is basically that wattless component Vi sin phi. Is this now understood? Is this now understood, everyone? Yes, basically LC oscillations. Power means bichara, pity. Yes, oh, I think Frederick also told that. Yep. Yes, L and C are the hero, R is the zero. Yes, Sai Shashank. Okay, power means sad, yeah. Yeah, looks like everybody told what power is. So cool, guys, understood. So, oh, by the way, this, how do you find that 10 amperes? Oops, where the hell did it go? 1 second. So going back to the previous question. So if you want to find the wattless current component, so guys, it is nothing but 20's sin phi. So 20 sin 45. Okay, 20 sin 45. So 20 by root 2. All right. Oh, but we had to find RMS. This was peak value. This was the peak value. This was the peak current. So the RMS value will be 20 by root 2 into 1 by root 2. So that will be 20 by 2, which is 10. So remember, this was the peak value. The RMS will be, into 1 by root 2, and hence you will get it as 10 amperes. Yeah. So, Sai Shashank, I just told you about quality factor as well, just some time back. Just rewind the session a little bit. You will see the definition of quality factor I just told you. In case you have forgotten that, Q is nothing but 1 by R root of L by C. That's the quality factor formula, direct one. Okay. Aditya, is it possible to score 170 in 2 months? Abhinav. Yes, Abhinav, I don't know which level are you at, but definitely please write in the comment section below. I'll help you out, or ping me on my Instagram handle Shreyas_Vedantu. I will help you out with a strategy. Okay, Abhinav? Cool. How about this question? When resonance is produced in LCR circuit, which of the following is not correct? Which of the following is not correct? Okay, come on. Peak current will be 20. Yes, Vicky. But we found out the component of it. So 20 is 1 by root 2 component. I hope you remember that. So Arvind, the class will continue for more 15-20 minutes. That's it. Okay. So remember, Vicky, we found out 20's component, which was the wattless component, and into 1 by root 2 to convert it into RMS. Vishruta, all the best, Vishruta, for your chemistry practicals out there. So Sam Niran, I hope you understood. I hope you understood when I was explaining it to Vicky. Okay. So I hope you remember that. Yes. So first we found out the component, the maximum values component, and then about this. Okay. So how about this question, guys? Come on. When resonance is produced, which of the following is not correct? Well, some of you are saying C. Well, I'll tell you what. Current in the circuit is in phase with the applied voltage. Yes, that is true. The voltage and the current are in the same phase at resonance, because the question is on resonance. There is no phase difference. Inductive and capacitive reactances are equal. That is also true because the value of XL, and the value of XC are equal. So basically, understand, they cancel out each other. That's why the phase difference is 0. So that is also true. If resistance is reduced, current will, if the resistance is reduced, current will increase. Think about it, current will increase, correct? If resistance is reduced, current will increase. Think about it. Now, if current will increase, what will the voltage across the capacitor do? The voltage across the capacitor is current into XC. V is IR. Voltage is current into resistance equivalent. So if current increases, voltage across the capacitor will increase. So even this is true, guys. Even this is true. Think about it. So now impedance of the circuit is maximum. That is the wrong option. In fact, it is not maximum, it is minimum. It is minimum. You have the least resistance at resonance because the current is maximum, the total resistance is minimum, so impedance of the circuit is minimum. So that's why D is the option. Very few people got it. So very good, all those people who have got the correct answer, D for this particular question. Okay, now just for the previous one, because some of you said I did not understand the calculation, guys, this 20 was the max value, correct? This was the max value. So what is the wattless max value? What is the wattless max value? It will be 20 sine 45, so which is 20 by root 2. Now the wattless RMS value will be 20 by root 2 which is 20 by 2, which is 10 amperes. Hence this was the answer. Understand, in AC circuit, whenever they ask you current or voltage, they never ask you peak current or peak voltage, they always ask you RMS. So remember, never give the answer in peak unless asked otherwise. Good that you asked this question. Only answer the questions in RMS value, never answer it in peak value. Remember that. Yes, I hope now it is clear. Okay, chalo, let's get going. Okay, how about this? My God, all gaming. Kirti Singh from class 9th. Well, Kirti, I think you are a little bit early for this class because this is a class 12th class, but definitely you can hit the subscribe button and keep, because eventually you are going to be with us after 1 or 2 years. Okay, how about this? There is a transformer and the number of turns in the primary is 300, in the secondary it is 150. Output power is these many watts. Secondary current is 10 amperes. Then input voltage and current are. How much is the input voltage and the current? Let's do this. Come on. Hello Sandeep. My God, your Cambridge exams have already started and you sat for the paper. I hope it went well, Sandeep. Let's do this. Guys, you know the output power. You know the turns in the secondary. This is the secondary coil. And the current in the secondary coil is also given 10 amperes. Remember, output power is output current into output voltage. So 2.2 kilowatts, that's why 10 to the power 3, output current 10 into output voltage. So this output voltage will be 2.2 into 10 to the power 2, which is 220 volts. Correct? This is 220 volts. Now remember the turns ratio formula. Secondary turns upon input turns is nothing but secondary voltage upon input voltage. Secondary by primary. But for the current, remember it is exactly opposite. It is input current by output current, because VO is equal to VI. Output power is equal to input power. Voltages into current are equal. Now, if you remember this, we can solve it very easily. The secondary turns are basically 150 by primary turns. Look at that, the primary turns are 300 is output voltage, which is 220 divided by input voltage. So naturally the input voltage will be, this is half, right? So it will become 440 volts. This is your primary voltage. Last thing over here, input current by output current. Input current I don't know, but output current is nothing but 10 amperes. So basically what am I going to get? 150 by 300 is equal to input current by 10. 150 by 300 is input current by 10. So input current will be how many amperes? 5 amperes. So that will be your input current. So I guess it should be option C. No, Kumar, it's not D. Well. That's how you do this. Hi, Dhruv, Kataria, welcome aboard. All those people who have joined in late, do not forget to hit the subscribe button so that you do not miss the new notifications. And do not forget to smash the like button if you are enjoying this class. If you have forgotten to smash the like button, please do it now. Come on, do that. Yep. Let's go to the next question coming up on your screen. That was answer C. And let's get going to the next question. Guys, tell me one thing. Do you now feel a little bit more confident on the chapter of AC? Do you now feel a little bit confident? Vicky, you can do one thing. You can just rewind the lecture a little bit. When I told about that love triangle, power triangle and all that, just remember hypotenuse is not the actual power, is the apparent power. Okay. The base VI cos phi is the actual power. The height VI sin phi is the wattless component. Just keep that in mind. Yep. Cool. Let's get going. Okay, Vicky, I just answered it. Very good. Very good, Sushruti. Very good, Pratiksha, Kora, Sri, Arvind, Naman, Chandresh, Pratiksha, Kumar. Very good, Yalini. Nice to know that. Guys, trust me on that. Initially, the formulas look different, difficult, very weird, not able to understand. But when you start solving problems with me, then you will actually understand those formulas. And that's why this Zero to Hero series is intended for. Okay, in a circuit, all these components are given. LCR, okay, alternating voltage source of frequency F. The current leads the voltage by 45 degrees. What is the value of capacitance? Let's do this. The current leads the voltage by 45 degrees. Very good, Frederick. First of all, current is here. LCR. If you forget whether L was on the top or bottom, remember one thing. This line is very important. What is it? Lavu is above all. Who is above all? Lavu. Okay, Lavu is above all. Remember that, guys. So if you remember this phrase, you will never forget this. Love is above all. Now, who is leading whom? Current leads voltage. So guys, when you actually add VL, VC and VR, the current should be ahead of voltage. That means voltage is behind. The total voltage is behind. This is 45 degrees. This is the total net voltage. Isn't that clear? So guys, who is more? Love is more or capacitance is more? Love is more or capacitance is more? Come on guys, who is more? Tell me. If total voltage is here, is VL more or VC more? Come on, think about it. Is love more or capacitance more? Think about it. If the total voltage, think about them like vectors VR, VL, VC. Total resultant is here. VC is more or VL is more? VL is more or VC is more? Think about it. Answer in the chat box. Okay. So Venkat, it is already there in the Pathfinder series. Pathfinder series is already there in the playlist. Just check the playlist tab of our channel. Yes, capacitance voltage is more because that resultant is here. It's like having three vectors like this. Obviously, the resultant will be here because this vector is more. If that vector was more, the resultant will be there. So, guys, what is going to happen is you can convert it into VR is over here. Okay, so basically resistance is over there. You can think of it like that. Okay, this is the resistance part. The net will be capacitance minus inductance. Think about it. Capacitance is more, inductance is less. So the net will be here and the resultant of them will be over here. Think of it that way. Yep. Think of it that way. The resistance is there. Anyways, that is horizontal because love is less, capacitance is more, inductance is less, capacitance is more. So when you add this and this, obviously the net will be here. It's like you have to add 5 and 2. What is the resultant of 5 and 2? Obviously the resultant is 3 downwards. 5 minus 2, correct? So if VC is more, VL is less, the resultant will be 3 downwards or C minus L downwards. That's what you should keep in mind for this problem. So guys, the current is leading the voltage. That means, remember this, resistance is here and you have XC minus XL below, and this is basically your Z, and this is 45 degrees. This is also 45 degrees. Now think and tell me, if this is 45, this is 45, this is Z, this is R, this is XC minus XL. Pradyumna, what did you not understand? I just said, because think about it, this is current, this is voltage. Current leads the voltage by 45 degrees. Since the voltage is behind, that's why the capacitive component should be more than the inductive component because of vector addition. Is that now clear, Pradyumna? Sriram? Okay. Now remember this. If this is 45, this is 45, can you comment on R and XC and XL? Can you comment on this? Think about it. Can you comment on it? I think so. You can comment on it. Because if this is 45, this is 45, can I know what are these two related by? I think both of them are equal to each other, because this will form a nice triangle, guys. I mean, think about it. If you shift this over here, if somebody had to shift this over here, all right, won't this side and this side be equal? Won't this side and this side be equal? So can I say XC minus XL is equal to R? Is everybody getting it? Yes, they are equal. I hope this is clear. Now, if this much is understood, what is XL? XL will be, think about it. What should be done next? Come on, guys. What should you do next? XC will be, how much is XC? XC will be XL plus R. Correct. Now substitute the formulas. It will be 1 by omega C, okay, is equal to omega L plus R, because that's just the formula. Now flip it. So omega C will be 1 by omega L plus R. So therefore C will be 1 upon that omega should be taken here, omega L plus R. Now just use one simple thing. Remember, this omega is actually 2 pi f. This omega is nothing but 2 pi f. Now check which of the options match. I think this option will match. Yes, this option will match. Okay, Chandan Prakash, I'll tell you what. Forget all this. Now remember one thing, guys. There are two kinds of triangles. One is resistance. So this is XL. This is XC. Okay. So when you simplify this triangle, if XC is more than XL, okay, you are going to get this like this, XC minus XL over here, and the resultant will be Z. This will be phi. Okay, I hope this much is clear. If XC is more than XL, then this much part will be XC minus XL, and the resultant of R and this much part will be impedance. This triangle or these sides are directly proportional to the voltages as well. So if you draw VR, VL and VC, okay, these sides are proportional to the resistance, because remember, voltage is current into resistance. Voltages are currents into resistance. So these lines are proportional to these voltage lines. Just remember that. So that's why, what are you going to get? You are going to get VR over here, and over here you are going to get VC minus VL, okay, VC minus VL, and this resultant will be the total voltage. Remember that. This resultant will be the total voltage, and this is also phi. So understand, both these lines are similar to each other. I hope now it makes sense. Is that clear? Frederick, we are starting with 11th standard series next week onwards. Okay, somebody was saying. Chandan, did you guys get it? Okay, bacha. Yep. In Arvind, I know in H.C. Verma it has been given in reverse, but solve it like this, it will be easier. Yeah, just follow my method. This will be easier for you to understand. Yep. Don't follow that H.C. Verma method now. Okay. Okay. Yes. Yes. Cool. Let's get going. Great. The answer is D, guys. So I know this is a very tough chapter because people don't solve it via vectors. They solve it via formulas. So please remember one thing that is to be like taken away from today's class is that, you know, solve AC problems via vectors, use trigonometry, angles, triangles, etc. The only things that you should keep in mind is XC is omega C, 1 by omega C, and XL is omega L, RMS is max by root 2, power is VRMS, IRMS cos phi, and the power triangle and the quality factor. Apart from that, love is above all, resistance is horizontal, capacitance is below. That's it. If you remember that, trust me, this chapter is very easy. You can solve them in a very easy manner. Now, if you guys do not know about our results which are produced in JEE Mains 2, let me just tell you about that. So from JEE Mains 1, we had 45 students above 99 percentile. From JEE Mains 2, 1 in 2 students from Vedantu has qualified for JEE Advanced. Yes, 1 in 2 students, and there are 11 students who got 100 percentile in physics, 6 students who got 100 percentile in maths, 2 students who got 100 percentile in chemistry just from Vedantu. Now, if you want to be the next topper, if you want to get 99 percentile, 98 percentile, 95 percentile, depends on where you are. If you are in 90s range, obviously you are aiming for 95, 99 percentile. If you are in 60s range, you want to come to at least 90 percentile. So guys, this is the last chance because you know the crash course is going to start early this week. So you can choose the dates by going on to the link. I'll tell you all the benefits of crash course first of all. See, if you just go to the link out here in today's video as well, you will see that there is a crash course link. If you click on the link, you will see when the crash course is starting. 5th April, it has already started. 26th April, that's just hardly few days from now, almost next week. 45 live sessions, and the crash course will end just before the May attempt. And it will have all the subjects, all the topics revision, plus problem solving, plus yes, test series, 20 full test series, which you can give whenever you want, along with the discussions which will be available. How the classes are, how the doubts will be solved, how the test series are, how what is the kind of support you are going to get, all of that is mentioned over here. So when you basically click on this and say buy now, you can get 40% off by using the coupon code SHCC. So when you say buy now, okay, so you just need to log in and you can go ahead, register yourself because the crash course is about to start in a few days. So do that guys, because it will be a life-changing opportunity for all of you, because this is the last chance before the May attempt examination. So thank you guys very much. Yes, Arvind, I know Arvind, in HC Verma the XC and XL directions are reverse. So but that will not matter. Understand, just follow my technique, because every book might have a different convention. Over there they take the vectors rotating clockwise, but I am following the standard convention where the vectors are rotating in phasor diagram anti-clockwise. So that's why things are in the reverse manner in some books. Okay, is there mock test mainly? Yes, there are mock tests, 20 full mock tests. Yes, correct. So Sudha, if you want to contact me for JEE classes, please ping me on Shreyas_Vedantu. That's my Instagram handle. So for 1 year course, there is a pro subscription, Jaya JEE 2022. There is a pro subscription. You can check out the link, which is again there in the description box of yesterday's video. Yep. So thank you guys very much. I'll take the classes at 9 o'clock. Yep. Thank you guys. Bye bye. I hope you enjoyed a lot. And if you have forgotten to like the video, please do that now. And please do not forget to hit the subscribe button if you are new to this channel. Bye bye. This was Shreyas here signing off. See you guys again at 7:30 in the Menti quiz for Pathfinder series.